Lesson 7. Greek columns and buildings. Greek columns are architectural elements that were widely used in ancient Greek architecture. They're vertical, cylindrical, or slightly tapered structures that support the weight of the building or structure above them. Greek columns are known for their distinctive designs and have been influential in architectural styles throughout history. There are three main types of Greek columns, each with its unique characteristics. 1. Doric columns. Doric columns are the simplest and oldest type of Greek columns. They're plain, sturdy design and typically fluted, meaning they have vertical grooves running down their length. Doric columns have no base and directly rest on the stylobate, which is the top step of the temple platform. At the top of the column there is a plain cushion-like capital called an echinus, which supports the entabulate above, which supports the roof above. 2. Ionic columns. Ionic columns are slenderer and more decorative compared with Doric columns. They have a base that separates them from the bottom of the platform. The shaft of an Ionic column is also fluted, but the flutes are more delicate and closer together than those in the Doric columns. The capital of the Ionic column is characterised by two spiral scrolls called volutures. So above the capital there is an entabulature, which is a block with a frieze that often features intricate carvings. 3. Corinthian columns. Corinthian columns are the most ornate and elaborate of the three types. They have a base similar to the Ionic columns and a fluted shaft. The capital of the Corinthian column is adorned with acanthus leaves, which curl and form volutes at the corners. The Corinthian order is known for its decorative details and often used in more luxurious and grand structures. Greek columns were not only functional but also served as an aesthetic purpose. They were used to create a sense of harmony, proportion and beauty in Greek architecture. The columns were often arranged in rows to form colonnades, which provide shade and created a visually pleasing effect. Greek columns have had a significant influence on architecture throughout history, particularly in the Western world. They have been adopted and adapted in various architectural styles, including Roman, Renaissance and Neoclassical. Even today you can see the influence of Greek columns in buildings, monuments and structures around the world. Column science, building strength under pressure. What you'll need for this experiment is about 20 paper cups, some sheets of A4 paper, some paperback and hardback books, baking trays or large sheets of cardboard, and your courage. First, take an empty paper cup and place it on the floor. Balance a sheet of paper on it. Note what happens. Add a paperback book. What changes happen? Now, replace the paperback book with a heavier hardcover book. What happens now? 5. Try standing on the cup. Does it bear your weight? Now, try a group of 3 to 5 cups. Repeat the previous steps and note what happens. Use a baking tray or sheet of cardboard to balance over the group of cups. Column science. Why does it happen? Many ancient civilizations, including the Greeks, used columns to strengthen the structure of their buildings and increase the stability. It's one of the reasons they're still standing after thousands of years. The Parthenon in Athens is built on opposable columns and lintel, which is a flat block system. But what is happening and why does it work? There is a direct relationship between pressure and area as long as other forces like weight stay the same. So if one increases, the other decreases. For example, if the same weight is spread over a larger area, the pressure will reduce. By the same principle, if the weight is concentrated on a smaller area, the pressure in that area increases. When you add too much weight to the single paper cup, it should collapse. This is because all the weight bearing down on it is concentrated in a small area. When the cups are spaced out and a flat sheet or support material like the baking tray or cardboard sheet is balanced on top before the heavy object is added, the tray or cardboard helps to spread the weight out over a larger space. This makes the cups better able to support heavier weights because each cup is taking only a small amount of the weight. The spacing will also make a difference because when the cups are too far apart and the weight is all in one place, the tray or cardboard will start to bend and buckle, as the weight will only be held a little by the cups at either end and there'll be no support in the centre. As you build up the layers, like more stories of a building, as long as the supporting structures are stable, they can bear a larger load. There will be a point where there is too much pressure, even with the weight distribution evened out, so there is a limit as to how high the build can be constructed. This is the critical stress point of resilience.